Reverse engineering is like taking something apart to see how it works. Imagine you have a cool new gadget. You want to know what makes it tick. So you carefully dismantle it. You examine each part. You figure out how they fit together. That's reverse engineering. In the world of computers, reverse engineering is similar. We take software or hardware apart digitally. We analyze its code or structure. This helps us understand its functionality. This knowledge is super valuable for ethical hackers. They use it to find and fix security holes. They protect our systems from bad guys. Reverse engineering is like solving a puzzle. It's challenging, but rewarding. Reverse engineering is not just about breaking things. It's about understanding how things work. This knowledge helps us build better and more secure systems. Ethical hackers are the good guys in the digital world. They use their skills to protect us from cyber threats. Reverse engineering is one of their most powerful tools. Imagine a hacker finds a new malware. This malware can steal your data. Ethical hackers can use reverse engineering to understand how this malware works. They can then find ways to stop it. Reverse engineering helps identify vulnerabilities. These are weaknesses in software or hardware. Hackers can exploit these weaknesses. By understanding these vulnerabilities, ethical hackers can help developers fix them. This makes our systems safer. Reverse engineering is also used to analyze suspicious files. Is that email attachment safe to open? Reverse engineering can help answer that question. Reverse engineering might sound complicated, but the basic process is straightforward. Let's break it down into simple steps. Step 1. Information gathering. The first step is to gather as much information as possible about the target. This could be a piece of software, a hardware device, or even a network protocol. Step 2. Disassembly or decompilation. This step involves breaking down the target into smaller, more manageable pieces. For software, this might mean using a disassembler to convert machine code into assembly language. Step 3. Code analysis. Once we have the disassembled code, we can start analyzing it. We look for clues about how the target works. We also try to identify any vulnerabilities. Step 4. Documentation. As we learn more about the target, we document our findings. This helps us keep track of our progress. It also allows us to share our knowledge with others. Just like a carpenter needs his tools, reverse engineers rely on specialized software to do their job. These tools help them analyze and manipulate code, making the process more efficient. Disassemblers. These tools convert machine code, which is difficult for humans to read, into assembly language, which is a more human-readable format. Debuggers. Debuggers allow reverse engineers to execute code step by step. This helps them understand the flow of the program and identify potential vulnerabilities. Hex editors. These tools allow reverse engineers to view and edit the raw binary data of a file. This can be useful for making small changes to a program's behavior. PE, or portable executable viewers. These tools are specifically designed for analyzing Windows executable files. They provide information about the file's structure, imported libraries, and more. Section 5. The importance of disassemblers and debuggers. Disassemblers and debuggers are the bread and butter of reverse engineering. They allow us to dive deep into the code and understand its inner workings. Disassemblers act like translators. They take the complex machine code that computers understand and turn it into assembly language. Assembly language is a low-level programming language. It's still quite technical, but it's much easier for humans to read and understand than raw machine code. Debuggers are like time machines for code. They let us execute a program step by step. We can pause the execution at any point, examine the values of variables, and even change the program's behavior on the fly. This level of control is invaluable for understanding how a program works. Section 6. Legal and ethical boundaries in reverse engineering. Reverse engineering is a powerful tool. Like any powerful tool, it's important to use it responsibly. There are legal and ethical considerations to keep in mind. In many jurisdictions, reverse engineering for security research is legal. This means it's okay to reverse engineer a product to find vulnerabilities. However, it's often illegal to use this knowledge for malicious purposes. For example, you can't use reverse engineering to create a pirated copy of a program. Ethically, it's important to be transparent about your actions. If you find a vulnerability, report it to the vendor responsibly. Give them a chance to fix it before you disclose it publicly. Reverse engineering is a complex field, and the legal landscape is constantly changing. It's important to stay informed about the latest laws and regulations. Section 7. Real-world examples of reverse engineering. Reverse engineering has played a crucial role in many high-profile security discoveries. Let's look at a couple of examples. Stuxnet. This sophisticated malware was designed to sabotage industrial control systems. Reverse engineering helped security researchers understand how Stuxnet worked and who was behind it. Heartbleed. This vulnerability in the OpenSSL cryptographic software library left millions of websites vulnerable to attack. Reverse engineering helped identify the flaw and develop a patch. These examples show how reverse engineering can be used to make the digital world a safer place. Section 8. The challenges of reverse engineering. While reverse engineering is a powerful tool, it's not without its challenges. 1. Complexity. Software and hardware are becoming increasingly complex. This makes reverse engineering more difficult and time-consuming. 2. Anti-reverse engineering techniques. Some developers use techniques to make their code more difficult to reverse engineer. This can include obfuscation, which makes the code harder to read. 3. Lack of documentation. Often, reverse engineers have to work with little or no documentation. This means they have to figure out how things work from scratch. Despite these challenges, reverse engineering remains an essential skill for security professionals. As technology evolves, so too will the techniques and tools used for reverse engineering. Section 9. The future of reverse engineering. As technology advances at an unprecedented pace, the field of reverse engineering is constantly evolving. New tools and techniques are emerging to tackle the growing complexity of software and hardware. Artificial intelligence and machine learning are playing an increasingly important role in reverse engineering. AI-powered tools can automate many of the tedious tasks involved in analyzing code, freeing up human analysts to focus on more complex problems. The rise of the Internet of Things presents both challenges and opportunities for reverse engineers. With billions of connected devices, there are more potential targets for attackers. However, reverse engineering can also be used to secure these devices and protect our critical infrastructure. Section 10. Conclusion. Reverse engineering, a powerful tool for good. Reverse engineering is a powerful tool that can be used for both good and bad. In the hands of ethical hackers, it's an invaluable asset for improving security and protecting our digital world. By understanding how things work, we can identify weaknesses and develop solutions to make our systems more resilient. As technology continues to evolve, reverse engineering will remain an essential skill for anyone interested in cybersecurity. Remember, with great power comes great responsibility. Always use your knowledge for good and help make the digital world a safer place for everyone.